Hello, everybody. Thank you for joining us on another webinar by Lachisoft. My name is Nick Zulfikar. I'm the Director of Client Services here. With me is my colleague Ron Hussain, who's our Senior Technology Evangelist. Today, we're going to be talking about handling EF Core relational data in NCache. As you know, EF Core is an object-to-relational mapping engine for .NET and .NET Core applications. It helps generate data access code for developers. They no longer have to write this by hand. It's similar to .NET and .NET Core. EF Core is cross-platform, so that means you can use this in Windows, Linux, or Mac. This makes it very popular, and it's primarily used for high transaction applications, which means that there's a lot of load on the database as well. So in today's webinar, Ron will talk about scalability and performance bottlenecks with EF Core, and he's going to demonstrate different strategies to create, to cache relational data, as well as synchronizing cache with the database for reference and transactional data. So with that, I will turn it over to Ron, who can take us through the webinar. If there are any questions, you can feel free to type them in the questions box on the right-hand side, and I'll jump in to ask those for you. So with that, Ron, kindly take over.
Very good. Thank you, Nick. Hi, everybody. My name is Ron, and I will be your presenter, technical presenter for this webinar. And Nick is going to help me, ask any questions that you guys may have. As Nick has mentioned, today's topic is around EF Core, how to go about caching. How to use NCache in EF Core, and first of all, why do you need a distributed caching system like NCache in an Entity Framework Core application? And then since Entity Framework Core primarily deals with relational databases such as SQL Server or any other relational data sources, we'll talk about what are the challenges that you face and how to go about those challenges and fix those with the help of distributed caching features. This is going to be a hands-on webinar. We have a lot of code examples that need to be covered. There are APIs and then there are extension methods that I will introduce as part of this webinar. So stay tuned and let me know if there are any questions. You can always type in and I'll be very happy to answer all those questions for you. Assuming everything looks good, I've got a few confirmations here, so I'll quickly get started. First of all, as Nick has already given you an intro, Entity Framework and EF Core, EF Core is the newer version of Entity Framework. These are object relational mapping tools for .NET and .NET Core applications. Primarily, they simplify your database programming. You don't have to work on the ADO.NET layer anymore. You can work on object model. And your persistence code, database access layer code can be generated with the help of these tools. You don't have to write these or go through the complexity of actually mapping your data model onto your object yourself. It's very popular, primarily with the release of .NET Core, which has made it cross-platform. You can now run .NET Core applications on Linux platform as well. On the same lines, EF Core is getting very popular for high transactional server applications. So I'll give you some examples. Primarily, this is EF architecture model, which should be applied on EF Core as well, but there are a lot of enhancements within EF Core, moving away from EF. Number one is the performance. It's cross-platform. It's modular. You don't have to have entire package, introduced into your application. You can just use the lightweight components that you need at the minimum, and you're good to go with the development. And then there are feature set which makes it very flexible. So you have object services. On the application side, you either use SQL or Link, and then it gets transformed into data provider. You have ADO.NET providers, and then those actually get executed against the database. And we'll talk about how to use caching and why do you need caching to start up. So first of all, I'll build some basic concepts. I'll talk about scalability. Scalability is an ability within an application to increase the transactional capacity and at the same time keep the improved performance in the application architecture. So essentially high application performance, and that too under peak loads. For example, you have a certain kind of latency, certain kind of performance under, let's say, 7 users, 10 users, or 20 users. If you're able to maintain the same kind of performance and at the same time you're able to attain the more transactional load capacity out of those users were, let's say, generating 50 requests per second. If you're able to handle 50,000 requests per second and, let's say, 100,000 requests per second, or have quantified based on the user load, if you increase the user load from 10 users to 100 users, from 100 users to 1,000, 10,000, so on and so forth, and without slowing down the application, that ability is actually categorized as scalability. So scalability is the prime requirement for applications which need to interact with backend databases. It could be a typical ASP.NET or ASP.NET Core web apps. It could be .NET and .NET Core web services, which may be dealing with a lot of end user application requests, or it could be a public facing application, e-commerce platform, some financial platform, some banking platform, airline booking system. So there could be many examples of ASP.NET web apps which are in turn using some web services to handle the data, but these are prime candidates. Where you can use EF Core as well to help achieve the linear scalability out of these. It could be IoT, it could be any other general .NET or .NET Core server applications which may be using Entity Framework Core as a backend database provider for that matter. EF Core applications scale out nicely. You can put a load balancer in front of your web app. If it's a web service, you can again distribute load on multiple application tiers. If it's a tiered based approach where you have a data access layer which is built as part of your web app, again, a load balancer can linearly increase the capacity. You can have multiple copies of that application on different web servers or app servers, and then you can scale out the application tier pretty nicely. But EF Core is eventually going to talk to a backend database. Let's say we have a relational database, SQL Server. That becomes a storage bottleneck. It's primarily designed for storage. It's very good for that, but when you improve when you increase the load capacity that it needs to handle under peak loads, based on our experience, database is not designed for such scenarios. It would choke down under peak load. It would slow down to start off, and then eventually it can choke down the performance of your EF Core applications. And this could impact the end users because your applications are waiting on those requests to be served, and database is just not able to accommodate those requests. And this is exactly why you need a distributed caching system like NCache. Primarily, it's super fast to start off. It's in-memory access in comparison to database, and then it's more scalable than your database. You can add as many servers as you need to into your caching tier. It's not just one server. You can have 1, 2, or 3 caching servers joined together. You pool their memory capacity and transactional load handling capacity. And then you have a very scalable platform out of it. And nice thing about distributed caching system like NCache, you can use it in addition to a relational database. It's not going to replace your relational databases. Your existing EF Core application using a database, that remains perfectly intact. And on the same lines, you use the distributed caching system of NCache alongside the database access. And we'll talk about how to actually get started with this. There are some approaches that we have lined up for you. This is a typical deployment architecture with the .NET Core. You can run NCache on Windows, on Windows Nano, or on Linux server using tar.gz or Docker approach. Docker is fully supported, but you can also go through tar.gz approach. And I'll actually show you this in our demo environment as well. And again, on the same lines, your applications could be either on Windows or on Linux because .NET Core is cross-platform. So is EF Core as well. So it could be your ASP.NET web apps, web services, or any other .NET and .NET Core applications deployed on Windows or on Linux environment. They can use NCache, again deployed on Windows or Linux environment based on your preferred platform. And you have your relational data sources used alongside NCache with the help of different approaches that we'll talk about in upcoming slides. Some important use cases, and then we'll dive right into the topic. You can use NCache for data caching. And again, you can use direct API calls, and it could be Entity Framework app, EF Core app. That's something that I've lined up for today's webinar, and I'll use that as a demo app. Then for ASP.NET, you can use it for ASP.NET or ASP.NET Core sessions caching. You can use ASP.NET and ASP.NET Core SignalR backplane. That's another use case for it. ASP.NET Core response caching, and legacy applications can use NCache for view state and output caching. So these are all providers with minimum or no code change options. In ASP.NET, there are no code change options. In ASP.NET Core, you just need to plug in the provider in startup.cs. So that's the, or you can drive this through configs. And then third important use case is that you can use NCache as a powerful messaging platform. It could be your microservices having app coordination. They need some data, they need some information to be passed on between one another. So you can build a framework around this using NCache as your messaging platform. You can have topics and based on your point of interest, you can subscribe and publish messages to those topics using subscribers and publisher model as PubSub is designed for. So NCache can be used as a messaging platform between your server applications. That's the third use case for it. All right, I think this is enough background. Please let me know if there are any questions in general about the caching or why you need a caching product like NCache in your EF Core apps. Next, I'll talk about application data caching, and we'll get started with basics. We'll talk about EF Core entities. Right. So typically, when you fetch a data from Entity Framework, EF Core, if you run a link query, you may be getting a single product based on ID, or you may be running a criteria and you're getting a collection of products. Now, from Entity Framework Core, it can return either of those. A single entity would be count, sum, or one product as a result of that. A query result could be a entire collection of products, orders, customers. So all those are typical use cases which you may encounter. So how to handle single entities and how to handle query results, and using NCache as an example. Let's quickly get started with this. Before we actually show you the code examples, first of all, you need to decide whether you want to use direct NCache APIs, which are very simple. You just need to start introducing NCache APIs. You can write a wrapper of NCache, which has add methods, get methods, update methods, or remove methods, and pretty elaborate ones as well. Or you can use built-in EF Core extension methods that NCache has provided on top of EF Core caching support. So we'll talk about both of these approaches. It's entirely up to you which one would you like to decide. Direct NCache APIs give you more control, whereas EF Core extension methods make it more simplified. So there are benefits in each of these approaches. So first of all, handling a single entity using direct NCache APIs. So I have a sample application lined up right here. So what I will really do is I will go to a get customer right here. So we have a single entity method right here. What it's really doing is, this is an EF Core app. I have just introduced the NCache namespaces as part of this so that I'm able to use this. So within direct APIs, all you need is web.caching and .runtime. So these are the two at the minimum that you need. So bringing back the get customer method right here. So typically in your application, you may be getting a customer ID and then you have a not-found context. What you really do is you first of all check whether that item exists in the cache or not, right? For that, you need a key. And this key formation is done by your, based on your application logic. I have come up with a sample key formation. In NCache, everything is stored in a key and value pair. So there's a string key and then there's a value, which is your actual entity. In this case, I'm dealing with customer. So I have customer with customer ID as a keyword, and then customer ID is a runtime parameter, which is passed on to this method. And then I'm trying to fetch that customer from the cache first myself. I'm not calling it any EF Core at this point. I'm just calling cache.get. So this is the direct NCache API call. Assuming that item may already exist in the cache, you might want to check in the cache first, and you don't want to go to the database, and you save expensive trips if it is indeed found from the cache, right? In cases if it's not null, which means I've got it from the cache, I would simply return the code from this point. I would return the customer from here. But in a scenario where you're running this query for the very first time, it could be that you may have to go to the database, get the customer, and then get the customer object added in the cache by calling cache.insert. So that your application has this customer, you return it, but before returning it, you also add it to the cache next time usage. For next time, you would have the items in the cache. So if if you go through this code again, you would always find that item in the cache unless this gets removed or gets expired. And we'll talk about how to keep cache in sync with the database, because we're talking about relational data. So we need to have all those challenges addressed as well. So that's how you would deal with single entity using the direct NCache API calls. Again, if you're dealing with collection, it's very simple. There are two options here. One option is that you store entire collection as one item, or you iterate through the collection items and store them individually. Either way, you have a collection. You're getting customers by city, right? So there could be many customers. Again, you construct a collection key. I am using customers because these are many customers, and by city, and customer city is the runtime parameter. And again, I'm calling cache.get, and I'm expecting a customer collection out of the cache because it's a collection. So I'll just return this customer collection if it's found from the cache. If it's not found from the cache, again, I'll run an EF core call and add it to the cache and return. Right? So that's how simple it is to use NCache APIs. We have a lot of features where you can set up expiration, set up some database dependencies, handle read-through and write-through. Data access layer providers can be plugged in. So this is all possible with the help of direct NCache APIs. So second approach is through EF core extension methods, and today's focus is more of it's more towards EF core extension methods. How to use EF core extension methods and be able to handle single entity and entity collections in EF core application. First of all, you need a NuGet package. You need alachi.NCache.ef core NuGet package to be added inside the application. Once you've done that, next thing is that you get this caching options. You have this from cache extension method. There are load into cache, from cache only. So there are many. I'll start introducing these methods one by one. But just to let you know that this NuGet package introduces all these caching options and these extension methods inside your application, and you can start using those. So first of all, let's take the example of single entity. If you have a single object expected out of the database, how to cache it and how to be able to use it. So what's the approach behind it? First of all, you set up some caching options, right? Let me show you the caching options class first of all. So you can set up some time-based expirations, some SQL dependencies, some storage type, some resyncing, with the database options. So since we're only talking about single entity here, so all you need to do is you specify store as separate entities. It could be a collection returned, but out of those collections you want each item to be stored separately. It could be one item, again it will be stored as a separate item. And then you run your EF core and you go with from cache extension method. If I go to the definition of this, it's the entity framework core extension method that we've implemented, and it allows you to give the key. Again, it's an out reference, so NCache constructs the key for you. It gives the options as part of this, and then it stores that in NCache, and you can simply return that customer to your application as well. So the way from cache works is it actually replaces the above code here, where you need to first check in the cache. If it is found there, you return from there. If it's not found, it would always go to the database. So this has been automated as part of this extension method. NCache has built-in logic where it checks in the cache. If it's found in the cache, it would return from cache. It would not go execute against the database. But if it's not found in the cache, it would execute against the database, add it to the cache, and also return. Right? So this is achieving the same task with just using the caching options construct, so that you store it as a separate entity or a collection, or set up some expirations, and then using the from cache. So we introduce our first extension method. This is how you would store single entity. And if you need to store a collection, again an example of this, you can cache each collection item separately, or you can have entire item stored as one collection with the help of extension method. So in that case, all you have to do is store as collection, right? So you're expecting a customer list to be returned as part of this method. You set up the caching options for NCache, and then you call the collection, the EF core query. From cache extension method is called. Caching options are passed, and again, if it's found from the cache, you don't go to the database. If it's not found in the cache, you would always execute against the database. Link is executed, and then based on that, it would return the and objects, and then also store it in NCache. And storage is again going to be through collections. So this is how you would store single entities and collections inside NCache, and we've given you some sample examples for it. Please let me know if there are any questions. This was pretty straightforward. Next thing that you should consider is what type of data from a relational data source to be cached in NCache, because relational data could be of reference nature or it could be of transactional nature. Primarily it's reference data, which mostly belongs in a database, but there could be some transactional data as well. Reference data is more reads than writes. It's usually a lookup data, products, employees. It could be an e-commerce application which needs to list down all the product catalogs. It does not change that frequently. It's not a static data. It does change, but frequency of change is not that great. And typically we recommend that you should have entire data cached in NCache so that you run all your Entity Framework core queries on NCache and you don't go to the database at all. Second type of data is transactional data. Transactional data is reads as well as writes. So data is changing and frequency is higher than your reference data. It changes every minute, every 5 minutes, 10 minutes, every hour, every day. It could be dependent upon the users who are logged in. It could be your orders. It could be your accounts. It could be any processing of data which is done at runtime. It's changing very frequently as well. And you don't have to cache entire data, transactional data in NCache. You can cache some, and for rest of the data, you can always go back to the database. So these are two kinds of data that we recommend that you should cache. But all of this data, reference data or transactional data, has relationships, right? There could be product dependent upon orders. There could be customer who has a lot of orders. There could be a one-to-one, one-to-many, and many-to-many relationship. So how to capture relational data? Let's cover that, and then we'll talk about reference and transactional data caching with the help of EF Core extension methods. So handling relationships in cache. Is there a question?
Yeah, Ron, I have a quick question here. What is the recommended approach to cache the data? Should they be cached separately, or should it be cached as a dictionary or a collection?
Since we offer both options as part of Entity Framework Core, so first of all, both are supported. My personal recommendation would be to use separate entities, because in that case you have every customer stored in NCache as a separate item in the cache. So if you need that customer, you can always fetch that customer and you don't have to deal with the entire collection. Similarly, you can run NCache link. There is an extension of link that NCache provides, which only executes against NCache. So you can run link queries or SQL-like search queries using NCache APIs directly on those items. So I would personally recommend that you go with separate entities, because it's lightweight to deal with individual items. Storage overheads are going to be a lot more optimized, and then access standpoint and manageability standpoint, this is going to help in comparison to storing as a dictionary or as a collection. I hope this answers your question. So I'll give an example of handling relationships, because cache is a key value pair. You have a key and then value, whereas relational data in SQL Server or your relational databases, those have tables. It's a structured data, and then those tables have relationships with other tables as well. So using Entity Framework Core, I'll give you a one-to-one or one-to-many example. Again, I have get region with territories. Let me just open this from here. This is my method. What it's really doing is it's getting all the regions, but territories are as part of it. So what I really have to do is store as separate entities using EF Core extension method within NCache. I set up the caching options, and then I ensure that I have include keyword used as part of link, which would demonstrate that this would be part of the region, and then I can simply call from cache and pass on those options. So it would store regions, and then it would store all the territories as part of the regions in the distributed caching system. So you have the complete relationship captured as part of this extension method and as part of the storage using the separate entities. So each region would have all of its territories as part of it. You can additionally go ahead and get the regions extracted out and then store them separately, but for that you have to use the direct NCache APIs, where you make first API call and store regions as separate item, then you get a collection of territories out of that region and then store them individually as well. More management, but would give you more granularity in terms of storage and in terms of retrieval as well. So relationships can be captured as part of EF Core by using our extension methods. I hope this was straightforward. Now, next two topics are going to be around reference data and transactional data. And main challenge that I'm going to help address in this particular webinar is how to handle synchronization. What are the common challenges and how to go about those common challenges when dealing with reference and transactional data. All right, so first of all, for caching reference data, read-intensive data, we recommend that there are two steps. First of all, we recommend that you load entire data into the cache. All reference data should be loaded in the cache. All products, all customer information, which you know that are static in nature. They are going to change, but you know the frequency of change, or ways to manage the synchronization, which I will cover in next slides. You should load all of the data in NCache so that you don't go to the database at all, as long as that data is valid in the cache, available and up to date in the cache. And then you always store them as separate entities. This would again allow you to query the subset of the data from the cache. You don't have to deal with the entire data. You can only deal with the subset of the data as needed. So first of all, load all products. I have a method lined up right here. So I have load all products method. Again, I'm using the caching options, using separate entities because I want to query at a later stage. And then I simply call this from products in database.products, and I'm calling load into the cache. That's the second extension method that I wanted to highlight. Previously, we were using from cache. Load into the cache is always going to execute against the database, but this is a one-time call. At your application startup, you should make sure that you load all your products, all your customers into the cache, and you don't execute this again and again, because this will always execute against the database. And it would never execute against the cache. It would not check whether it exists in the cache. It would just go ahead. It's a loader like a feature where it gets the data from the database and adds it into the cache. So that would just complete our step one, where we have entire reference data cached in NCache. Now, next thing is that you run from cache only for your reference data. How to go about it? There is a new extension method, a third extension method. We've covered from cache, then we covered load into the cache, and then we're going to cover from cache only. From cache only is always used in combination to load into the cache. We assume that data is already loaded, and we assume this for reference data primarily. Now, all of the reference data is already in the cache, so you don't have to execute against the database. So this method is always going to execute against the cache. So that's the behavioral approach. So we have a discontinued products. We query based on discontinued flag being true, and then we execute against the cache only. Now we have data already cached using load into cache. Once this would run, this would only run against NCache, and this is a NCache link, being executed with the help of from cache only. It's not going to execute EF core commands at all. This is built into the support of EF core caching, where we execute against the cache only. And if data is available in the cache as the entire data set, you can run a subset out of it. You can run any other query. Select a product where product.id is something, or product.price is greater than 10, or product.price is less than, let's say, 100. Again, those where clause are going to be executed against the cache, and a subset can be retrieved out of the cache once you have all the products in the cache. Notice we reloaded all the products, then we ran a discontinued search, all the products which were discontinued out of this, and using from cache only. So that's how you should plan on caching the reference data. Load all of them in the cache, and then use separate entities, and then search based on the items in the cache using NCache link. Now, for transactional data, you have to work, on the same lines, but with slight difference that you only need the working set. You don't need an entire transactional data in NCache. Why? Because data may be changing in the database, and you may be, changing that in NCache, and this could be very costly to start off. And then you only need the working set out of it, the user-specific data, the customers, information which are currently logged on. The current orders which need to be processed, current accounts which are active at that point, or current user related data that user is most readily accessing at that point in time. So there are two options. Again, you can cache entire collection as one item, or you can cache them individually. It's entirely up to you. Either way, it is going to get the job done. If the collection is not too huge, store entire result set as a single item. If collection is huge, I would recommend that you store separate entities separately in that case. And for that, we have get customer orders. That's next. Let me just quickly show you that. Right. I'm using some other attributes here, but let's assume that first of all we are going to store as separate entities, and then we're getting the customers and we're calling load into the cache. Or we could simply use the from cache construct, if that's something. Let me just find that right method for you. There you go. All right, so we have this get customer orders from cache. Again, I would store them as a collection. That's my first example. I'll just run a query against EF core, and then I'll use from cache, which essentially means if it's in the cache, it will get it. If it's not in the cache, it will execute against the database and fetch it for your applications. And I'm iterating through this. There's something that I can do in my application. That's entirely how you want to do this. Other approach could be that I can store this as a separate store as. Let me just give you that idea as well. All I have to do is store as separate entities, and it will just store all of them individually, and you have individual items available in the cache as well. So entirely up to you how you want to design it. So these are two examples which cover this. So please let me know if there are any questions at this point. We've covered half of the content as far as relational data is concerned. We covered handling relationships. We covered direct and cache APIs and EF core extension methods. And within EF core extension methods, we've talked about how to handle single entity, how to handle collection, how to handle reference data, and how to handle the transactional data. Next segment is going to be the database synchronization or challenges involved in keeping cache fresh in regards to database. So I'll give you a quick hands-on example. I'll set up the environment for you and show you this sample application running so that you see this in action, and then we'll cover the next segment where we'll talk about keeping cache fresh in regards to database, and again in regards to reference and transactional data, and keeping in view that all data is relational in nature. So please let me know if there are any questions at this point. Otherwise, I'm going to move on and get started with hands-on portion real quick. I have two sets of servers.
So I have a question here, just popped in. Are these items also dependent on each other? Basically, if one gets removed, the dependent also gets removed?
Yes, you can set up ways, and this is exactly what we'll cover. There are ways where you can set up dependencies, and those dependencies could be key-based dependencies, where one item gets expired or removed, the other one automatically gets expired. And this could also be extended to the database as well, where if database gets changed, you automatically remove or update the items in the cache. So this is all lined up for our next segment, where we can use these features. All right, so let me quickly get started with the hands-on portion, the demo of the product. NCache can be deployed on Windows environment as well as on Linux servers. So I'm going to use GUI tools on Windows, and I'm going to use PowerShell tool on Linux. Both are PowerShell support is available for Windows as well as for Linux. But just to get you a flavor of GUI as well as PowerShell, I'll be using two different environments for this. So I have NCache management tool, GUI tool on Windows. I'll quickly get started and create a named cache. Let's say EF core demo cache, right? You can name anything. It could just be EF core cache. Let's keep it simple. Let me just copy this name here, and I'll just pick partition replica. There are 4 different topologies that you can choose from, but I'm going to go ahead with partition replica because it's most recommended one. Async is faster. This is the replication mode between the active partition and the backup. Sync is more reliable. I'll go with async because it's faster. And then I have demo 1 and demo 2 are going to be my 2 servers which are going to host my cache. So I'm going to go ahead with the default options for everything else. TCP IP port for communication between servers. Size of the cache cluster. So I'll just give 1 gig per server. And then I'll keep everything simple. Auto start to be enabled so that each time my server gets rebooted, cache automatically starts up on this server, and choose finish. and that's it. That has started, created my cache on 2 servers. Let me see if I can add my box. As a client node, there you go, and this completes our configurations using the GUI tools. So that's how simple it is. Now you just need to start using your applications to connect to it. I'm going to test this cache cluster right after it gets started with a dummy stress test tool. But like I mentioned, you can get started with your actual applications as well by using the NuGet package and using either the direct API calls or the extension methods that I was highlighting at startup. All right, so my cache is started. I'll right click and choose statistics. This would open perf counters in a separate window, and I can also choose monitor cluster. This would open NCache monitoring tool, which comes installed with NCache. Next thing is that I just need to run a stress testing tool application. Again, for that, I can open the PowerShell. I just need to use test-stress. That's the name of the tool. I think it just takes the name of the cache, and that should be good enough. And it should start simulating. There's one client connected, and we have activity on server 1 as well as on server 2. Both servers are taking requests, and you should see some graphs being populated on NCache monitor as well. So that confirms that everything is configured fine. On Windows environment, you can use all of this with the help of PowerShell tools. There are many commands. For example, you can use create cache with new cache command, right? And then you could also have add node to that. There's a PowerShell, and then you use add client node. So all of that, what we've done in this GUI tool, where we created a cache, specified 2 servers, and added the client node, they can be achieved with the help of PowerShell tools as well. As a matter of fact, let me run some commands real quick. For example, we can start this cache cluster using the start cache command. I have already created a cache for you because of time constraints. This demo cache is created on 2 servers, so I'll just run the start cache. Demo cache server is 115, and I'll quickly start this cache on 115. 115 and 116 are 2 boxes where my cache is configured already, so I just need to start these. So 115 has successfully started it. I'm going to start on 116, and then next thing is I'll list the caches by using get caches PowerShell, and it started with 2 servers completely, and I'll do the same for 116 as well. To demonstrate that it is actually all right. So it's started here as well. And next thing is that I need to run the stress test tool for my demo cache. Let's see if it runs by default, and it should have some activity. Nice thing about NCache is that you can monitor a Linux based cache cluster using .NET Core Linux deployment of NCache on Windows box as well. And primarily there are no perf counter support in Linux environment as yet, so for that you have to rely on Windows, and that makes it very flexible in terms of monitoring. I just need to specify one of the server nodes, and I have demo cache running here, and I can right click and choose statistics, and this would open a custom view of perf counters which NCache publishes. Let me see if there are any errors. Let me see if it takes dash server so that it's pointing. Let me find the command from here, because actually it takes cache name. Anyways, so this is how you would test it. I'm not, since I didn't use the Linux environment as yet, so I'm having difficulty. Maybe it's pointing to another environment and it's saying no server is available to process the request. So it could be a firewall issue, but anyways, this is how you monitor the Linux-based cache cluster using the Windows set of servers. And again, you can run anything on the Windows natively, because the NCache is supported on .NET as well as on .NET Core, again on Windows, and then on .NET Core you can also use the Linux environment or Mac or Windows Nano, and again you can use the Docker or Tart.gz approach for either of these. So this was a quick demonstration of the product. I will move on to our next segment, because we have a lot to cover in this one as well. So how to keep cache fresh in regards to reference and transactional data. Now that we've defined that there could be reference data, there could be transactional data, and data could have relationships, and for that you have ways to handle relationships. But for reference data, how to keep cache fresh, because we have entire data in the cache, and for transactional data, how to keep cache fresh, because it has a subset of the data in the cache. So issue here is that since you are keeping entire data set in the cache and using from cache only executes against the cache, database can change, right? So whatever you have in the cache, you always get returned with that, right? Could be stale data in the cache, whereas database has been updated. So how to go about and fix this issue? First of all, for reference data, you need entire data in the cache and data in single entities, and you only use from cache only. So there are two options, two ways you can handle this. One is that you use expiration, but with auto reload feature. NCache has implemented this auto reload feature, and we have a sample implementation as part of this. If I quickly show you this, first of all, you have to store. Let me give you an example from here. Load all products, right? So what you really need to do is, let me just show you the load all products method first. All right, so first of all, you need this, you need to store as separate entities, and then you need to load into the products. Let me open another sample, which is the working sample for this, and I'll show you the load all products. All right, so this is something that you would normally use, but with the help of first approach, where you use expiration and auto reload feature, you need to copy, you need to use this set absolute expiration, datetime.now, add hours. Let's say 10 hours is what you want to keep in the cache, and with an assumption that each time it gets expired, you would automatically reload it. And for that, you would use the resync provider name. So this is something that we've built as part of it. So inside the options, you can set up options dot, and you can set up the absolute expiration time, and then you can also set up the set absolute expiration, and you can also set up the provider, read through provider, right? So once you've set up the resync provider, you need the resync provider, which is part of this sample project right here. And inside this project, we've given you a sample implementation where NCache would go ahead and call this provider automatically. It would construct the key for you. It would call, you just need to set up the initialization and load from cache source is the method which gets called, and you set up the same caching option that you were setting up for reference data, and you would simply, call the data access layer through EF core or through .SQL from SQL against calling EF core. And it constructs the customer objects or order objects from the database for you. So the way it would work is that you would store separate entities, you would set up time-based expiration, and you would set up some expiration, some resync provider to automatically reload. So after 10 hours, you would get the updated value, and with an assumption within those 10 hours, after those 10 hours, items would change in the database, and updated values would automatically be brought into the cache. So idea here is that your entire database reference data from the database, entire reference data is brought into the cache. You store them as separate entities, set up expirations with automatic reloading of NCache. Second option is that you don't use expiration and you manually reload, right? So what you really need to do is call this EF caching, this method right here, after certain intervals. Let's say after 5 hours, or let's say if you have 1 hour expiry, after that you automatically call it. So it executes against database only, so it would automatically reload it. So that's the simplest approach, which can be a sequential option, but gets the same job done. The idea for reference data is the entire data set should be in the cache, and you save your expensive trips to the database. You shouldn't be dealing with partial responses from cache or stale data, and for that you should use either SQL dependency or use expirations for that matter. So this is all the code to tackle the handler, the resync provider, automatic resyncing, and then expiration code for that matter. Now for transactional data, it's even simpler because you have subset of the data. So you should use short expiration, but don't auto reload because data may be changing very frequently, right? Usually it's 5 to 10 minutes of expiration. So from cache will fetch updated records if those are expired from the cache. So get customer orders. Let's use that as an example. All right. So all you have to do is you can simply create separate entities, use the expiration. Let me just set up the expiration. Let me copy it from here. So you can say options.set absolute expiration, and then you give an and it takes a new date time, right? Let me just see if it actually takes a date time, so it's not a time span. So you just need to say date time dot now dot let's say add minutes, and I give 10 minutes to it. Sorry about the lag here because I'm having a hard time. This is a logged in environment. So you set up the expiration, and then you don't set up any resync provider, and you store everything in separate entity, and then you call from cache here. I think this is using load into cache, which is another example. So I just have to call dot from cache, which should take care of the method here. And if it's expired after 10 minutes, you don't have it in the cache. So it gets executed against the database, and you fetch the item in the cache. So this is exactly what this is doing. It's getting orders, and it's setting 10, let's say 60 seconds of expiration or 10 minutes of expiration, and after that you automatically go to the database. So that's how you keep cache in fresh in the cache, and data in the cache to be fresh in regards to database. For reference data, you should use some kind of expiration and use automatic reload feature of NCache. Sample implementation is available. And then second option is that you don't use expiration, but after certain intervals you manually reload. So you always have an older copy, and after you expect that data needs to be updated, you automatically call, you manually call the load into cache method for that. So load into the cache should be called after, let's say, every 10 minutes, every hour, every day. That's entirely up to you, where you manually reloading data yourself and you're not expiring anything. So why you should focus on reference data in such a way that entire data should be in the cache? Because if you get a partial data gets expired and it's not in the cache, it's not reloaded in timely manner, you would lose some of the data, and you query that data, and if it's not available, you end up with incorrect results, and you really don't want that. Since you're storing entire data in the cache, so you should either use auto reload. With the idea behind auto reload is that it would not remove items, it would update them. Or don't use any expiration and manually reload yourself. And for transactional data, it's very simple. You simply need to set some expiration and use from cache. Don't use load into cache or from cache only, because that's primarily for reference data. I hope this was pretty straightforward in terms of examples. Please let me know if there are any questions. With EF Core, you can use aggregate operations as well. Aggregate operations returning entities or values. Again, you can use from cache, where you have first or default. Again, you have a count. Again, you can use from cache only for that matter.
I have a question, Ron. For the auto reload option, can there be multiple read-throughs in case there are multiple databases that we are accessing on the back end?
Absolutely. You can have, you can even specify the name of the read-through, right? So if you notice within this, we have, this resync item expiration flag set to true. Let me just quickly show you this. Set resync provider, and you specify the name of the provider. For separate entities, let's take an example where customers are handled by one resync provider, so you can have a provider just for that and register with NCache. And registration process is very simple. You need to go to the cache and you need to set up the provider with NCache right here. So you can have multiple providers, and you can specify names of different providers based on the entities, based on the logic that they're able to do. So yes, it's possible.
Thank you.
Very good. Next segment is around the general architecture. I'll spend 5-6 minutes around it because overall we've covered some major concepts around relational data, how to capture relationships, how to handle single entities, how to handle collections, and then we expanded on top of it, and then we talked about reference data caching, transactional data caching, why you should keep entire reference data in the cache and use queries, and then why a working set for transactional data is a good idea, and then how to keep reference and transactional data fresh in regards to database using expiration and reload features. I hope it was pretty straightforward, but if there are any questions, you can always send us emails and we can specifically work with you on that. Typically, NCache is a very elastic cache in terms of extensibility. You can extend it on multiple servers. It's highly available. It's linearly scalable. You can add as many servers as you want to. So first of all, it's TCP-based TCP/IP-based cache clustering. There's no single point of failure. You can add or remove any servers into the cache, and you don't have to stop the cache or any of the clients which are connected to it. It's 100% peer-to-peer architecture with 100% high availability built into it. There are various caching topologies, so you can scale out. There is an active partition, and then there's a backup on the same server, so you can have active backups. Server 1's backup is on 2, server 2's backup on 3, server 3's backup on 1, and you can choose async or sync replication, and by help of this you can scale out by distributing data on multiple servers and eventually distributing the load on multiple servers and attain linear scalability out of the system. There are some extended features such as client cache, so local near caching is part of NCache, where you can have further performance boosts by keeping a local client cache on your application boxes, and you don't even have to go to the server cache for your EF Core apps for that matter. And this is a fully synchronized cache, and it can also run inside the application process as well. And idea here is that you save your trips to the server cache across the network, and subset of data is in the client cache, and if data exists in the client cache, you don't have to go to the server cache. Again, NCache manages the entire operation of client cache with NCache. It also comes with WAN replication, so if there are multiple data centers, entire cache data can be transferred to another data center cache. Between two caches, you can set up a bridge. It's part of the same product and allows you to copy data from one cache to another. It could be active-passive for DR scenarios, one-way transfer, or it could be active-active where both sides are transferring data to one another. And at any point in time with async replication, you would have both caches in sync with one another. So based on your use case, east to west migration, for maintenance, for DR, you can use the bridge cache very easily. Some of our customers, and that pretty much covers the technical content that we had lined up for this. A quick summary around this. First of all, you should use caching to help achieve all the bottlenecks that you have with databases. And then we talked about direct NCache APIs and extension methods. We talked about caching relationships, and then we talked about reference and transactional data and how to keep cache fresh. So this is it in terms of technical content. I will hand it over to Nick. Nick, please let me know if there are any questions.
Great, thank you very much, Ron. Thanks for the informative discussion around the EF Core and how we can use NCache to improve its performance and scalability. Guys, if there are any questions, kindly type them in. You can always reach us by sending us email at support@alachisoft.com for technical inquiries, and sales@alachisoft.com for if you would like to pursue investigating NCache a little bit more. You can download it from our website at alachisoft.com, and we have NCache and the latest version available there. If there are no more questions, I'd like to thank everybody for joining us today. We have another webinar scheduled for day after tomorrow. Same topic, so for a different audience. So if you would like to revisit this, have any pending questions, kindly join us then. And otherwise, we'll see you in our next webinar. Thank you, and have a good day. Thanks, Ron.
Thank you, guys. Thanks, Nick.
Bye-bye.